So today we are going to discuss yield keyword. First of all, why we need this and in which scenarios we should use it. Before that, let's see that how for each loop works. Right? Let's say we have a array of integers, ints like 1, 2, 3, and we want to iterate on top of that array. So what we can do is for each, and we can go for a loop, right? And when we run this, we will have that the integer from that array printed on the console this way. Let's say we just want to print those integers um, where the integers are even numbers, right? So what we can do is if I remainder of 2 is equal to 0, then we just want to print those words, those numbers, and in this way we will be printing I think there is an error. So in that case we will be printing only 2. We can see that, that's fine as well. And what if we want to return the results from a method? So what we can do is we can extract a method from this. What we can do is id add the factor extract method, and we can name this method as let's say uh, get even numbers, something like that, and we can rename that as well, get even numbers, right? Okay, the output will be the same, but now we don't want to print from that method. We just want to return a list or array of those integers. Let's say we have that list here, new list of integers, and we just want to push those even numbers into that list, and we can remove this. Okay, so this is the way we can get those even numbers here. This way, and we can iterate, we can turn temp. Okay, we can return temp like this, and we can find list of int, right? Okay, so here we can now apply for each, and we can say int and here we can say tab, and here we want even en numbers like this. Okay, so now we are basically iterating on that array, and Whenever there is a even number, we are putting that even number into our even list, and we are returning that list at the end. So our temporary list is involved, and we can use any other collection or generics here uh, to use as a temporary container. So this is one way, right? And what will be the output? Let's see. The output will be the same, 2, as we know that 2 is the even number. So let's expand our array to 4, 5, 6, 7, 8, 9, 10. This way, and if we double check now, we will have those even numbers printed on the console: 2, 4, 6, 8, 10, right? So that is fine, but we can see that there is a consumption of resources in that method, and that can be reduced by just using the yield keyword. How is that possible? Let's have a look. So let's say we don't want to create a list here just to increase the performance of our code, right? We don't want to consume extra bytes of memory, and instead of doing temp add, why not let's use yield return I, right? And we don't need this return anymore, right? And instead of I list, we can say I enumerable of ints, right? So I enumerable is sports iterator. So we will have list of those even numbers as a result of this calling method. So if we can see the number of lines are reduced. If we calculate or benchmark this code, now the number of bytes allocated are reduced, and the time it will take to execute that code will also be reduced, right? So how that yield keyword work? Whenever in that sequence, in through that iteration, whenever there is an even number, it will be returned straight away in that particular iteration, right? And it will keep iterating the main loop unless there is no more elements in that array. That is what we are passing. Or the other option is, if we want to break this iteration in case of yield, we need to explicitly break that for each loop. How we can do that? Let's say we have a condition that if I is equal to 10, we want to break that, you know break that loop. So we can do that by doing yield break, right? So, and if we run that now, what we can see that the output will be the same, just the 10 will not be included in those, in that list of even numbers. So let's give it a try. Now we can see that we have 2, 4, 6, 8, 10 is missing. To further explain this, what we can do is, let's expand our sample size to, let's say, 11, 12, 13, 14, right? Now the sample size is big, and we want to, and then let's comment this line, and if we run, we will have all those list of even numbers: 2, 4, 6, 8, 10, 10, 12, and 14. And if we want to break that for each, whenever there is a number 10 in that sequence, we can see that again the output is 2, 4, 6, and 8. So anything other, in that list or in that array after 10 will be ignored because there is no further iteration happening because we already have breaked that for each loop, right? So this is how just by using a yield keyword we can reduce the code number, code size, the number of lines in our function or code, uh, the memory allocation because no temporary list is involved, and the performance will be increased because it will take less time to execute that code, right? So this is how yield keyword help us. Then the question is what exactly yield keyword does. Whenever we want to iterate a collection which is, let's say, array, list, or anything which has a sequence of elements, we want to iterate those, um, customly, right? We want to provide custom iterator, we will use yield keyword, right? Because yield keyword remembers what it has returned in previous iteration, right? And it will keep iterating unless there is no further element in the sequence or we explicitly break the for each loop by using yield break keywords. So from now onwards, whenever you need to iterate the list or array or any other collection, and you have a custom logic, let's go for the yield keyword instead of doing or um, allocating memory by using temporary containers. No need for that one. So this is our yield keyword help us. We don't use normally yield keyword, but it's there from C# 2.0. That's enough time it's there, but we hardly use that. It is very useful. In some of our next video we will try to benchmark this code, right? Just to give you guys the stats that how much difference is there whenever we use yield keyword instead of normal approach, and how much time it take and how much bytes we can save by using that yield keyword. So I will going to push that code into the repository. You can check out the repository and run this code on your own system or just check this code on the GitHub. I will come into next video with some more C# related ideas. Till then, take care. Goodbye.